All right, so this is your video notes. I recommend lowering your voice level because most likely this will be very loud on your headphones. But go ahead and title this Unit 4.4 or 4.14, Graphing Parabolas in factored form. Okay, so everything that you are showing here is everything that I'm writing on my paper should be exactly on your paper as you are annotating. Okay, so I recommend having a colorful pencil or a highlighter if you are a person who likes to annotate in that way. All right, so let's go ahead and read this problem. So it says, a science class designed a ball launcher, testing it by shooting a tennis ball straight up from the top of a 15-story building. They determined that the motion of the ball could be described by this equation. So here we have this equation, and you'll get a second video, and in the second video, they'll represent this h as h of t, which just means the same thing as your output. Okay, so that is your output. So if you want to go ahead and annotate this, you can call this h of t equals this, okay? And so from here, we have h of t equals negative 16 t squared plus 64t plus 80. And we can go ahead and annotate here and say where t represents the time the ball is in the air in seconds, so time in seconds, and h represents the height in feet, okay, of the ball above the ground at t time. So here we have, with a graph, we can see the number of seconds it takes for the ball to reach its peak, okay, that's a key thing, and how long it takes to hit the ground. That's also a key thing. How can factoring the expression help us graph this equation? Okay, so most likely we're going to be working with a parabola because this is the formula for, or we already have a structure for a quadratic. So if we have a peak, most likely our ball is going to look something like this, right? So a parabola that's concave down. And peak, meaning it's probably going to have some type of maximum. So go ahead and keep on annotating in your notes. So here it says how long it takes to hit the ground. So at one point we want to figure out when does it hit the ground. But let's answer this question. How can factoring the expression help us graph this equation? Okay, well, we can change this quadratic into, so we can change the quadratic to factored form. Okay. Why do we want to do this? This is so that way we can determine the zeros or the roots at which the parabola crosses the x-axis. So here, change the quadratic to factored form to find the roots or zeros that will cross the x-axis. Okay, so here we can go ahead and actually factor this out. So we have this, we're going to set this equal to 0. So we're going to do 0 equals negative 16t plus 24t plus 80. Okay, now you could start with box method, but this would be too large of a number to factor. So always we want to check to see if we can get a GCF. Okay, so you always, when factoring, just remember if you can take the GCF first, that's great, and we can simplify this and it will make our lives a lot easier. So let's go ahead and do that. There is a GCF here, and it's going to be negative 16. Because negative 16 can be divided by negative 16, 24 can be divided by negative 16, and 80 can be divided by 16. Therefore, the GCF, the greatest common factor, is negative 16. So here we can go ahead and write this as 0 is equal to, we're going to factor out a negative 16. And so this will become, oh, this is t squared. This will become t squared minus 4t minus 5. Okay, and then from there we can go ahead and factor this trinomial, what's inside the parentheses here, to simplify further. So when we do that, you can do box method on the side, and you'll get negative 16 and two binomials, which are t and t, 5 and 1. And we'll get minus 5 and then plus 1. Okay, so then from here, we are able to determine the roots, but I'm going to have us come back to this in a second, okay? But this is how factored form will help us, and we can go ahead and save this for right now. Just go ahead and box this. We can move on to the next question. So here it says, once we have the function in its factored form, which we do, so this is the same thing, this is in standard form, this is in factored form. So what do we need to know in order to graph it? Okay, so what we need to know are a couple things. We need to know the zeros or the roots. This is a little like square. We also need to know the y-intercept. We also need to know the axis of symmetry. I'm going to abbreviate. And we also need to know the vertex. Okay, so these are the 4 things that are very important for us to determine in order to, this is a typo, we want to sketch, not graph. So in order to sketching, these are the 4 things that we need to know. So we can find the zeros or roots first, and we're going to use that. We're going to use our factored equation to help us with that. Okay, so right here I'm going to take this negative 16 t plus 1 t minus 5 over here. So you're going to write negative 16 t minus 1 times t minus 5. We're going to set that equal to 0 in order to determine the zeros or the roots of this parabola. So once we do that, once we set it equal to 0, we can divide this by negative 16 to get rid of that negative 16. 0 divided by negative 16 will give us 0 still. And then here, the negative 16s will cancel out. And then we'll get t minus 1 times t minus 5. And then there we can apply zero product property and set these each equal to 0. So t minus 1 equal to 0 and t minus 5 equal to 0. And then from there, we'll get t is equal to 1 and t is equal to positive 5. Oh, wait, did I do this right? Hold on. Oh, I didn't copy this. Oops. Okay, my error. So this is t plus 1. Just go ahead and change this to plus 1, plus 1. So this should be plus 1. There we go. And so we should get t is equal to negative 1. Great. So once we found, we can give it a little check right here. We found the zeros. So what we can do now is begin to sketch. So in this little chart here, we can go ahead and make an, best as you can here, a y and x axis. So here we can label this as x and y. And here, this x represents our, we're comparing time. So in this case, we can call this time. And then our y, or in this case, I'm going to use the same variables, so I should actually do that. This is t, it should be t for time, and then h for height. Okay, so this is our height, and then this is our time. Okay, so what we can do is, since t is equal to negative 1 and positive 5, we can write negative 1 right here and put a plot So t is equal to -1, and then t is equal to +5. So 1, 2, 3, 4, and 5. T is equal to +5. So from there, we are able to find the axis of symmetry. So I'm going to use, remember, the axis of symmetry is the imaginary line that kind of cuts the parabola in half. So we're going to go ahead and go towards the middle of our, between the two zeros. We're going to start there, and then we're just going to work inward. And they both meet right here. So our axis of symmetry is right here. And that's at 1, 2 when x is equal to 2. So we can give a little check. We found the axis of symmetry, which is great. And remember, the axis of symmetry is something that we can use to find our vertex. So we have to use some algebra piece here. So I will use black. Okay. So here, if we create a t-chart, we have our input, which is t for time, and then we have h of t, which is our output. So our output and our input. All right, so if we want to figure out at what point is it where it's the highest, well, we already know that in the middle, x is going to be 2. So we want to figure out when the time is 2, what is the output, or what is h? Okay, so we can use our factored form, or we can use the original in standard form and figure that out. So we can substitute, is what I'm trying to say. So we can find h of t, and I'll use the factored form to substitute in this case. I can use -16, I'm going to leave space, +1, -5. And what I'm going to leave space for is so I can write in 2. Right? So from here, I can go ahead and solve, and I'll get -16 times 3 times -3. And that will end up being, when you type this into the calculator, we should get 144. So once you do that, we get 144. So all this means is when at 2 seconds, the ball is at 144, what did we say height was in? I think in feet, right? Yes, in feet. So it's in feet. So when it's at 2 seconds, it's at 144 feet. So when you're sketching, you can go ahead and kind of give your own little tick marks, and they don't need to be super accurate, but we have 50, 100, 150, and then 200. We can stop right there. So 144 is somewhere maybe like right here. So you're going to kind of like pause right there, and that's where our vertex is at. So our parabola, I can try to draw this as good as I can, looks something like this, where this is the vertex. When the time is at 2, the height is at 144. Okay, so now that we found the vertex, we also need to find the y-intercept. And so the only way to find the y-intercept, if we use this chart again, well, the y-intercept is always determined when the time is 0. What is the height, basically, when the ball when the ball launcher launched from the building? Okay, so if this is my favorite one to substitute in, because here all we need to do is leave space for 0. So I'll use, since we're substituting in for 0, and I'll use this color for 2 because that's what I used. Okay, so here we can substitute in 0 and 0, and then there we'll get -16. 0 plus 1 is 1, and then 0 minus 5 is -5. And when you type that into the calculator, you type in -16 times 1 times -5, we'll get 80. Okay, so what that means is that when the ball didn't even start being launched, it's at the height is at 80. So that means our y-intercept is somewhere right here, where it's 0, 80. And usually you'll notice that this last term, your constant in standard form, is going to be your y-intercept, which is your initial starting point. Okay, This piece, you'll hear me say this in my second video, but this piece is probably the hardest part is sketching, because you have to know you have to get all of these little steps here, the vertex, y-intercept, zeros, and axis of symmetry. Everything else that follows is super easy because we've already labeled everything. And so all these additional problems here are very, very quick to answer. So right here it says, at what time, so go ahead and annotate, it says, using the sketch, at what time does the ball hit the ground? Okay, well, we only have two options where a parabola hits technically the ground, at -1 and at 5 seconds. So can we have -1 seconds? No, that makes no sense. So here we can say at 5 seconds. And then we're done. Over what, and this is a little weird, but over what domain is the ball rising, and over what domain is the ball falling? This is very interesting. So when we talk about domain, it's saying like which x values is the ball rising, and then at what x values is the ball falling. So remember, domain is like what values make sense. So right here, we can say, if I use a highlighter, let's say this yellow piece, or you can't really see that, so this orange one, that's from this point to this point, that's when the ball is rising. But from here, going down, that's when the ball is decreasing or falling. So what we say is the domain here is the, so the ball is rising. The ball is rising from, so the domain, it's the x values from 0, when x is 0, to all the way up here, which is 2. So it's rising from 0 to 2, and the ball is falling from 2 to 5. Okay, so so that is what it's saying here. Or you could say this: the ball is rising from 0 to 144. Or here we can say, or from 144 to 5. Okay, those could work too. So using the sketch, what is the maximum? So here we have maximum height of the ball reaches. Well, the maximum height is where the vertex is at. So at 2 seconds, we already said this already, at 2 seconds, the height is at 104 feet. So right here we can say at 104 feet. All right, that's it. So like I said, the remaining questions are pretty easy to find, but it's just understanding all of this piece, A and B, that's pretty hard. But it's not so bad. It's everything that you've learned, just all condensed into one problem. So go ahead. I want you all to write your summary. And you can move on to the next video. And that would be your homework. So making sure you're prepared for that and getting started. All right, that's it. Bye.